Hello everyone, and welcome back to science class. So last time we talked, we started discussing the periodic table. Specifically, we talked about the metals, we talked about the metalloids, and we talked about the non-metals. So those are the large major groupings on the periodic table. But the periodic table is actually organized into smaller groupings, and it's organized into other groups called periods. We're going to take a look at that today. So the first thing that I want to look at today is something called periods. Now, the periodic table is called the periodic table because of the periods that it organizes by. Now, the periods are the rows that the periodic table has. So that means going left to right, across the table, we have our periods. Now, if we were to look at the periodic table, you can see that the top row only has 2 elements inside of it. So the first period only has 2 elements in it. And as you go down the table, more and more elements get added to it. In total, we have 7 periods. Now, the periods actually dictate how many electron rings or electron shells there are in the atom. Let's take a closer look at what I mean by that. So if we take a look at this model I have of an atom here, if you notice, there are 2 rings that surround the red nucleus. There's the inner ring that has 2 electrons attached to it, the blue ones, and then there's an outer ring that has 7 electrons. Now, this atom is the fluorine atom, and it is found in the second period of the periodic table. Second period meaning that it has 2 rings. If this was a different atom and it was found in the 4th period, it would have 2 more rings. It would have 4 rings in total. So the periods are the groups of atoms across the table. Now, if you look at this periodic table, you will actually see that there are columns that are color-coded. Take a look at this one here. This first column is color-coded in blue. The next one is color-coded in orange. And then this last column over here is color-coded completely in pink. Now, that's no coincidence. We also organize atoms in columns. We also call that groups. So the up and down of the periodic table is considered to be a group. Now, the thing that makes the groups a group is when you look at their outermost shell. We have this thing called a valence electron, or multiple valence electrons. And the groups are determined based on the amount of valence electrons they have. Let's take a closer look at what I mean by that. So if we look at our fluorine atom once again, and if we take a look at the outermost shell, when we count, we see that there are 7 electrons in the outermost shell. Now, those are our valence electrons for this particular atom. The number of valence electrons corresponds to its place in the periodic table in the group. So if you were to look at fluorine on the periodic table, you would find that it is in column 7. Group 7, 7 electrons. If this was a helium atom, it would have a full valence shell, meaning that it would have the proper allotted number of electrons per shell, and it would be completely full. If this was a hydrogen atom, it would have only 1 valence electron. If this was an aluminum, which is located in the 3rd column, it would have 3 valence electrons. Let's take a look at the different groups that kind of stand out in terms of chemical properties. So we have this first group here. Now, the first group includes hydrogen, but at the same time doesn't really include hydrogen because we call the first group the Alkali Metals. And we know that hydrogen is in fact a non-metal. However, it has similar reactive properties. So the first column here, or the first group, has only one valence electron. Now, atoms or elements want to have a full valence shell. They don't want to have extras or extra space in their outer shell. So because these ones have one extra, they're going to want to react with other elements. Probably more on this side where they have an extra space for an extra electron. So these alkali metals are incredibly reactive. They're the most reactive metals of the entire table. When we look at the second group, these are called the alkaline earth metals. They have two free electrons. They have two valence electrons. And of course, they have extra electrons they want to get rid of. They're not as reactive as the alkali metals, but they're still pretty reactive. In fact, if we look at these two types of metals, these two groups of metals, we won't find any of them as a pure metal in nature because they're so reactive, they're going to react with other elements and they're going to form what we call molecules and compounds. Now, if we look at this green portion right in the middle of the table, they are a special group of metals. They're called the transition metals, and they have different chemical properties than the other two groups that we talked about at the beginning, the alkali and the alkaline earth metals. The transition metals are a little bit more stable because they're more central to the table. They tend to be harder metals, and a lot of these metals tend to be used in construction and other things like jewelry making and that kind of stuff. So you're going to find iron and gold and silver within these transition metals, as well as like copper and nickel and all that kind of stuff. So those are the more stable metals, and you'll actually find those as metals in nature. Now let's take a look at some of the non-metals. If we look at column 7, right here, this one in bright red, those are what we call the halogens. Now, the halogens have 7 valence electrons. They are allowed to have 8 valence electrons, meaning that they have one empty space. So because an atom wants to have a full shell as much as possible, they are going to react a lot to get that one electron space filled up. They are the most reactive nonmetals in the periodic table. Now, the last group on the periodic table that I want to take a look at today is in column 8. Right here. These are what we call the noble gases. All of the atoms in that column have a full valence shell, meaning that all of the spaces that are allotted for electrons in their outer shell is taken up by an electron. They are the most stable out of any of the elements on the periodic table. So stable that they don't react with anything. They're non-reactive. And they're called the noble gases because they're all gases. So, to summarize, the periodic table is grouped into 3 major subcategories: the metals, the metalloids on the staircase, and the nonmetals. Next, we group them into more specific things, such as periods. Periods are the rows of the periodic table, and we have 7 periods. We start counting from the top down. Each period tells you the number of electron shells. So for instance, if you are an atom located in the 4th period, you have 4 electron rings. Then we have a look at the groups, which are the columns. The group number tells you how many valence electrons there are in the outer shell. Valence electrons are the number of electrons that are located in the outermost shell. So if you are in column 5, you have 5 valence electrons. If you are in column 8, you have a full valence shell, and therefore you are not going to want to react at all. Thank you for listening, and I'll see you next time when we start talking about the different models and structures that we use to describe atoms.